from a well. So what is the depth? The depth of this is given. D is given. So it has to lift the water from a depth and it should project with a velocity V. For that, what is water? This pump should do? It should do work, no? mgh. Then it should project with a speed V. So it should lift the water to a height h. Then it should project with a speed V. So, but here some power is involved, no? So what to do with power? So I'll differentiate dw by dt. This is the power lambda gh. This is lambda v square by 2. What is the lambda? The rate at which the pump draws the water. That was the lambda. dm by dt, you can see the cubic meter per second. So what should be the lambda? Lambda should be equal to 2. So this is what? 2 meter cube per second. gh we know all. So substituting will get. But he's asking now something, if the power consumption of the pump is given by. Why that efficiency also he brought? So what is the efficiency? This is what the power what pen is needed, no? And for that what pen power. Okay, we'll define that this is power supplied. This much of power supplied to this and this much of power what happen it generates. So therefore, what is the power supplied? Now we can do one thing. If the power consumption of the pump is given by power consumption is telling. So I think this is, let me write here like this. So what is the power consumption? Equal to power generated by the efficiency. What is this P? This P should be power generated. Because why do this 80% is brought 0.8? So here the reason is some losses will be there. No, there'll be some friction. Even the pump itself will have some moving mechanical parts. There'll be viscous drag. There'll be friction between them. So therefore, the efficiency will put around the 80%. So this is the total power what it consumes. In which open this is what the useful power. What is this useful power? This is what you can say power supplied to the pump. Like this, what happen will differentiate these things here. This is what useful for us, no? It is lifting from height and it is projecting the water with a speed V. This is what useful power. This is what we supplied. So how much power we supplied? Is it all utilized? No, a part is lost. Where do this remaining part has gone? The 20%. It is used to overcome the friction between the moving mechanical parts of the pump, or there'll be friction between the water and the pipe. So for that purpose, it will be utilized. So when we go for viscous diagram, there will analyze some problems related to this loss in power. Are you getting no? So here is asking about the work done by the pump to lift water at a height h and project that water with a speed v. This thing. So differentiate this. The dm by dt is what? The rate. So what do you expect? No, this lambda. If you want more water to come out per second, tell me what you should increase here. You should increase power. No, if you go for 5 HP motor, what happen? More amount of water you can pump per second.